Alright, so you want to combine and simplify with complex numbers. What we're going to have to know before we start is that I and j are going to be the placeholders for imaginary numbers. Okay, and in this case, we're just going to use j. And then we also need to know that the imaginary numbers, so j to the power of 1 is equal to j to the power of 2 is equal to -1, j to the power of 3 is equal to -j, and j to the power of 4 is equal to 1. And these rules will apply throughout the questions, and the questions will get harder and harder. Okay. To start, we got question A. So question A, this one's fairly simple. So for most of these problems, it's just kind of algebra. Okay, it's just algebra, but we're adding the fact that we have certain values for the j's here. Okay, and so for this one, it doesn't look like there's anything crazy here. -j, right? Let's do BEDMAS or PEDMAS first, the multiplication. And we have -j2, and we can leave the 3, put -4, and then j3 here. And I'll go through these questions fairly quickly. We got 10 questions we're going through. And so I might skip a few steps, but for the most part, it is just algebra, okay? Most of it is algebra. And so for this one in specific, what we have is like terms. And when you're combining like terms with imaginary numbers, you want to do the real numbers separately, and then you want to combine the imaginary numbers. Okay. So 3 and -4, if you combine them, you get -1. And then if you combine -j2 and positive j3, you get a positive j1. But positive j1 is the same thing as just j. So we can write plus j here, and this should be the answer for A. Okay, so now for question B. Question B is very similar, except we have one small caveat, and that is that we have to distribute the negative sign. So let's do this side first. So let's do the BEDMAS here, so the multiplication, right? And so we will have -1, and then we'll have -j2. Okay, right? -j times 2. And then on this side, we can imagine it as like a negative sign, right? Or a -1. And we can distribute this with this and this with this. Okay, so -1 times j is -j. And then -1 times 4 is just -4. And now we can combine like terms. Okay, so -1 and -4 is the same as -5. And now if we combine these two, -j2 and -j, we get -j3. And that is the answer for question B. Okay. Now question C. Question C, a little bit harder. Okay, now we don't really have any BEDMAS that we can do, or anything that we can do right away. And what we have is we have fractions, right? Obviously, you can make this into a decimal number, but it's easier to keep things in fraction and then at the end give the actual answer in rectangular form. And so what we have here is we have something like this, right? We have a bunch of fractions. So we'll write out the fractions, okay? But we got to make sure that we're combining the fractions using the real number to the real number and the imaginary to the imaginary. So what I mean by that, let me explain it a little bit more clearer. We have the 1/2, and then we have the 1/4, right? So we can solve for that separately, and then we have to solve for the imaginary. Okay, so this is negative, right, over 6. And now we're just doing basic addition, okay? We're just doing addition. So in addition, we're trying to find the same denominator. So 2 times 2 equals 4, right? So it would be 4. And then if we multiply the numerator by 2 as well, we would get 2, right? And so now this is our equation, 2 plus 1, so we do the numerators first, which is 3, and then we leave the denominator. So 3/4 is our real number. And now for our imaginary number, what we have is we have the 3 at the bottom, right? And the common denominator between the two is 6. So You can multiply this by 2 and this by 2, numerator and the denominator. And so we would get 6 and then 2j, right? Or j2. The order doesn't matter, just letting you know. And sometimes I'll even switch it myself, okay, in this video. Just by nature, okay? And so now this is our equation. So j2 minus j is the same thing as just 1j, right? So we can just write j. And then the denominator stays the same. And so these are the two values. So this is the imaginary, this is the real. And we can just add them, right, as the final answer. Okay, j6. Let me make this lowercase to make it more clear. And this is the answer for C. Okay, so C, this is our question. Now we have D, so D. D, there's multiple ways of solving this. You can go one by one, but here's kind of like a cheat code or like a little like kind of technique that you can use for this type of question specifically. So for these questions, you can, where you have to multiply all of these, you can actually just do all the real numbers and then do all the imaginary numbers separately. So what I mean by that is you can do 5 times 4 times 3 times 5, and then j times j times, or sorry, times j. Okay, and what we can do is we can do these separately and then combine them at the end. So 5 times 4 is 20. 20 times 3 is 60. And then 60 times 5 is, let's do 600 divided by 2, and then that's 300. So we should get 300. Okay, so 300 is our real number. And then for imaginary, we have j to the power of 3, right? It's the same thing. So j to the power of 3. The thing is, right, now we're getting into what we're trying to remember from before, and that j to the power of 3 is the same as -1, okay? Or negative j, sorry, negative j, okay? And so what we have here is we have the answer as the combination between the two. So negative j, 300. You can also write it as negative 300j. It doesn't really matter. Just do whatever your professor says to be on the safe side. And that is the answer for this question. Okay, now for E. For E, now we're getting into a little bit more algebra, okay? So now we're trying to distribute these. Okay, so j5 times 2, right, that's 1. And then another one is j5 times j3. Okay, so now we got to solve these two. So when you're solving these two, we got to do the real number first. So let's do the real numbers, so 10. And then j is left alone, okay? So j is left alone. There's not another j, so we're not going to do anything. This is just 10j, or j10. And so on this side, there's one problem here. We have 2 j's here. So let's do the real number first, 15, right? 5 times 3 is 15. And then j to the power of 2. Well, j to the power of 2 is the same thing as -1, if we remember. Okay? So what we can do is we can do 15 times -1. That should give you -15. And so the answer is actually going to be, it's going to be -15. And then we have plus 10j. And that is the answer for E. Now F. Okay, so for F, what we have here is we have the 5, right, minus j3, but it's multiplied by 2 terms here. And so what we can do is we can apply FOIL. So if we remember FOIL, or distribution between two multiplications, it's basically the first number with the first number and the first number with the second. And then you do the same thing with this one, this term. You do this, and then you do this. Okay, so we have this, and now what we can do is we can actually we can solve for all of these individually. So 5 times 8, right? That's 1. And then we have 5 times 2j, that's 2. Negative 3j times 8. And then negative 3j times 2j. Okay. So now we can solve for each of them. So this one's 40. 4 times 8 is 40. Now let's do the real numbers for these two. So it's 10j, right? And the imaginary. Now, this one's kind of a little hard to see, but this one, we can do negative 3 times 8, and then we should get negative 24, right? And then j is left alone. And now we're multiplying two j's, okay? So let's do the real numbers first. So negative 3 times 2, which is 6. So negative 6. And then j2. Okay, but if you remember, j2 is the same thing as negative 1. So we can rewrite this as negative 6 times negative 1. And then if we multiply two negatives together, we get a positive. So it would be positive 6. Okay, so now if we rewrite this over again to make it easier to combine the terms together, negative 24j and positive 6, right? So now what we can do is we can add the real numbers, so 46, and then we can add the imaginary numbers. So we have 10 minus 24, which is negative 14, and then j minus j, you can just leave that as just j, okay? And this is the answer for this question, okay. Okay, now we're trying to simplify g. So g is very similar to the previous question, so we're gonna have to use FOIL. Now this is a similar kind of question, so I'm not gonna do all the parts to this, right? I'm not gonna go through every single line, but I will try to go as thoroughly as possible. So the hat is kind of the symbol for the power sign, if you didn't know. So it'd be this to the power of 2, which is the same as just writing this, right? We're just doing this and multiplying it by the same thing. Okay, so right here, this is what we have, and we apply FOIL. So 5 times 5, 25. 25. And then 5 minus j2, well, the real numbers, 5 and 2 is 10, and there's a negative sign, so negative 10j. And then for this term over here, we can do negative j2 times 5, and that's the same thing as we did before. So that'd be negative 10j. And then this one, let's go to the side a little bit, and let's do this one. So negative j2 times j2, negative j2. So you can do negative and negative, so it's going to be positive, right? Positive 4. Okay, so let's do the real numbers first. So positive 4, so let's do 4. And then j times j is j to the power of 2. Now j to the power of 2 is the same thing as negative 1, so let's rewrite this as 4, and then negative 1, sorry, here, and then we should get negative 4. And so this would be the final term, and then we can combine like terms, okay? So 25 minus 4, 21, and then negative 10j and negative 10j is negative 20j. And that is the answer for this question. Now for question H, what we have here is we have 4 plus j2 divided by 2. And this is the same as 4 over 2 plus j2 over 2. And what we do is we can cancel these out. Divide this by 2, right? Or divide this by 2, sorry. And this should give you 2, right? So what we have is 2 plus j. And 2 plus j is our answer. So 2 plus j is the correct answer for h. And what we have here is we have 8 over 4 minus j. Okay, so let's do this. And now what we do with these is we multiply by its conjugate to get rid of the denominator in a way. So the conjugate is basically the same thing, but we flip the sign. So let's do 4 plus j. And then at the top, we have to do whatever we do to the bottom. So 4 plus j. Okay. So now that is the same thing as, okay, so 8 times 4, 32. 32, 8 times j is just j8. So plus j8. Okay, so that's going to be our numerator. Now for the denominator, we can do FOIL. We can distribute these all. And let's do that really quickly. 4 times 4 is 16. So 16. 4 times j is just 4j. So deposit 4j. 4j. And then for this one, we switch to this side. So negative j4, which would give us negative 4j. And then negative j plus, or times j, sorry, is just negative j to the power of 2. Okay, so now that we have this, we can combine the like terms here. So these two, the positive and the negative, these guys cancel out. And we're left with 16, negative j2. But we know that negative j2, or j2, sorry, is actually the same thing as negative 1. Okay, so negative 1 would be this, and then negative 1. And we can imagine this as negative 1 times negative 1, which would give us plus 1. So this is actually 16 plus 1, which is 17. Okay, and so what we have in the denominator is 17. So now we can write the final fraction, or the final equation, let's say, as, or expression. We can say it's 17 as a denominator, and then we can do 32 plus j8. And that should be the answer for question I. Okay, now for question I, it is somewhat similar, as we're going to have to multiply by its conjugate. That's what it seems like. So let's do this. Let's rewrite the equation. So let's do negative 9 plus j3 divided by 2 minus j4. Okay, so we have this here. And I want to write this 9 a lot better because it does not look right. Let's do this. Okay, so we have this. Yeah, so it looks like we're going to have to just multiply by its conjugate. So we do 2 plus j to the 4. No, not to the 4. It's just j4, sorry. You can easily get mixed up when you're writing it. So be very careful and mindful of if it's to the power of, or if it's just multiplication, or it's a part of it. And so what we do to the bottom, we do to the top. So 2 plus j4. And now we can do FOIL. So FOIL for this, let's do that really quickly. Feel free to pause the video and do it yourself. Negative 18. Okay, so negative 18, let's separate this. Negative 18. 9 times 4 is 36. So 36, so negative 36. Negative 36j. And then for this one, let's do this times this, so 6. Right, positive 6j. Okay, and then j3 times j4 should give you 3 times 4 is 12, so 12. And then j power of 2, and this is the same as negative 1. So 12 times -1 is -12. So this should be negative at the end. Now what we can do is we can do the combination of all of these. And so what we're going to have, I'll write at the bottom here. Actually, let's do this first. So 2 times 2 is 4. So 4 over here. And then we can do 2 times here, which should give you positive 8j. And now for the j, so negative 4j times 2, which is negative 8j. And then what we can do here is we can do this times this, which should give you 4 times 4, 16. So negative 16, negative 16, negative 16. And then we know j times j is j to the power of 2, which is -1. So -1. And then this should be a positive number. So it should be positive 16. So this is positive 16. Okay, now we can combine like terms. So let's combine like terms. Let's move down a little bit. Apologies for the cut. I had to do something really quick. Okay, so we were at combining like terms. So what we have to do is combine the top. So let's do the numerator. So negative 18 and negative 12 gives you negative 30. And then negative 36j and 6. So we're just adding 6 to this. So it should give you negative 30j. And then for the denominator, 4 and 16 is 20. And then these two cancel out. And so this should be the answer for the question. That is pretty much it for me. It was a pretty long video, right? But we went through a lot of questions, and I hope you learned something. So thank you for watching, and I'll see you next time. Bye.